Hello fellow ship spawners! You are arriving again to the dark and twisted devlog dimension for the development of Omega Gateway, a work-in-progress 4X sci-fi game made by and for fans of classics like Master of Orion 2 and Star Trek Birth of the Federation. On the last log entry we managed to spawn a ship entity using our newly drawn ugly UI. The existence of a ship is represented by the player's icon on that sector that it is in. Today we are going to work on getting that ship moving, but for that we need to set a few things in place first. First of all, an event system for the churns. I started the development trying out an observer pattern structure for handling the churns. This means that whenever we press the next churn button, this object, most likely the game manager, will be in charge of calling all the subscribers in a list and letting them know through an interface that the churn has passed. I almost went this way, but then I noticed that Unity has a system in place for this exact behavior, Unity's delegates. It works basically the same, the only difference is that the notifier class has to have a delegate object and an event object. Subscribers that want to know when a churn has changed have to add a method directly to it, and whenever it is called, every subscriber will be called with the parameters you set. For the UI manager, for example, this will be the churn number, so we can change it on the top right, like this. With that out of the way, let's build some components to support selecting things and hovering on things. I was playing around with several ideas over the week to see what's the best way to handle these two things and keep the code clean. So after some deliberation, this is the plan. For elements that show info when they are hovered, I'm just adding a collider component and a mouse enter and on mouse exit actions on every class that need one. I thought about going with an interface like hoverable, but then I realized it didn't make a lot of sense for the limited amount of code we are adding here. For the time being, when you are hovering over these classes, you call the respective method and from that one the UI manager to set the info on the new text box on the bottom of the screen. It's currently looking like this. I really like how it looks. We can also set a hide method on the mouse exit so we clean that info box when we leave the object. But now going to selecting stuff. This one is more interesting for several reasons. First, selected things will show more than a small info text. In fact, it should open its own info panel with its own characteristics. For instance, when selecting a system, it should show the planets that it has and the features those have. When selecting a fleet, it should show its composition, available actions and the possibility to move it around the map. So this time we are going for an interface, an iSelectable interface. Everything that can be selected has to implement this. We are also going to build a component for selecting stuff and to hold the common behavior of the art of selecting, like identifying if you are left or right clicking. We will call that selectable entity, and the first thing we will try when it starts will be to get the iSelectable component. If it doesn't find it, then it shows an error. You can't just add this on any object, it needs to implement that interface. Then the behavior when clicking. We will use Unity's event system for understanding if the cursor is on top of a specific object. Again, it's showing a red underline, but I promise it is working. So if we left click on an iSelectable, so it's input.getMouseButtonDown 0, we are going to call one of the interface methods, Unselect. We will also do the same with the right click, MouseButtonDown 1. And we will call the other method of the interface, onAction. So any entity that wants to support being selected and being right-clicked has to implement the interface iSelectable, and thus have to override the methods onSelect and onAction. In the future, as we mentioned, we will add more specific UI that will be shown for specific onSelect actions. But now let's work on moving the ships. Before that though, a small change on how we define ships. In a past episode we created an abstract ship class and we were going to expand ship types by inheriting that class and adding particular behavior. However, we are changing the approach. Ship will be a concrete class and every ship variation will be a different prefab variant with different values and different class components if needed. This will allow us to take full advantage of Unity's instantiation features and setting different models way more easily. So let's add the Unselect behavior to the ships, and for that we will add the new iSelectable interface to our ship presence indicator. We must implement the Unselect and OnAction methods. We can leave OnAction empty for now, but for Unselect we will create a small field on the game manager to support the idea of a selected iSelectable. This will allow us to get what's selected from anywhere on the code, given that our game manager is a singleton. So on our Unselect, on the ship indicator, we just set itself as the new selected item. Now, although the behavior starts from the ship's presence, the action happens when you hover over a sector. So on the onHover method in the Galaxy Sector class, called by the onMouseEnter event that we defined earlier, we will call the game manager to get the selected iSelectable. Then we will use the is keyword to understand if that iSelected is in fact a ship indicator. If it is, we will call a new method to handle a selected fleet. To test if this works, we will draw a small circle in the middle of the sector and show it only if we are hovering over the sector and hiding if we are not, or we don't have a ship indicator selected. As you can see, this works wonderfully. Let's get our ship to move, shall we? I've been doing some thinking about what's the best way to execute the order between turns for ships, especially when having a long list of coordinates to follow. Where should these parameters live? The plan will be the following. We will create an abstract ship action class that will hold a dictionary with actions as keys and an object as a value. These will be the parameters that our action will read. We will also add an abstract doAction method that the concrete action type inheriting from ship action will have to implement with its respective parameters. Then we will create the moveAction class that inherits from ship action. The constructor will just take the ship and the parameters, but the doAction method that we are overriding will do the magic. Fair warning though, even when using the most of polymorphism with object values like this, there are more elegant ways than passing on a dictionary with simple strings as keys, but for the time being this will test the structure holds the test of time and debugging. But because we are using simple strings as keys and simple objects as values, we need to verify if we have everything we need to move the ship. So we check if among the keys of the parameters we have a location string and if that key is a galactic coordinate class object. This structural validation is all we do here, but the business logic, like for instance if the coordinate is a valid spot for moving into with this ship, will be done on the ship logic itself. If everything is valid, we call the move function of the ship with the coordinate as a parameter. Of course, we need to define it first. It will be pretty simple though. Given that most of the heavy lifting regarding how we render the ships are handled already on the sector and the ship indicator class, we can take a ship from one sector and put it into another. We will define the ship left sector and ship right sector methods in our Galaxy Sector class, but as you can see, they just add or remove the ship, and they can call the function to render the ship presence icon if needed. We are just missing one thing: how to pass the move action. Remember that the iSelectable interface also has an abstract method for right-clicking? Let's mess with that. So, same way we did with the onHover method, on the onAction method we will check if we have a selected item from the game manager and check if it is a ship indicator. We will wrap the code in this small private method that will just take the coordinate of the sector in a list and push it into the method for the indicator class to handle the action. Why a list, you may be asking? Right now we are moving to one coordinate, but in the future we want to queue several ones with a path-finding algorithm. Spoilers! Before we go to implement the movement though, we forgot to add something to hold the ship actions we defined before on the ship. Given that these actions make their effect once you change turns, we can define a queue of ship actions as a new attribute in the ship class. Then we will have some simple methods to play with this. A queue action that just adds an action to the queue and clear actions to clear them. We must also not forget to subscribe the ship class to the game manager on the next turn event with our own method. That will take the first action from the queue and execute it. Did we just say subscribe? That's the word of the day! Don't forget to subscribe to the channel if you like what we are doing here with Omega Gateway. So now that we can queue actions for ships, on the ship indicator class we can define the handle fleet movement method. Here is where we should address things like the speed of the ship, but we can do that later. For now, we will iterate through every coordinate we are sending as a path, and for each one we do an elegant call on a method using a for each link queue. This will tell all the ships in the list to clear their action queues, and then we add the new move action. This move action will have the ship itself as a parameter, and the dictionary of parameters defined previously with just the string location as the key and the coordinate we are going as a value. That should be it. The ship moves from one sector to the other between turns. The ship indicator checks for ships in the sector and renders the player owner's icon if there is one. There is a clear business logic issue here though. The ships are teleporting to the indicated sector instead of drawing a path there. But worry not, my friends, we will be implementing a pathfinding A-star algorithm in the next episode, and this will find the quickest way to reach a sector ignoring all the non-walkable ones. Thanks again for watching, and don't forget to like the video if you really dig into what we're doing here. By the way, we're trying to get into the first 100 subscribers! In any case, goodbye my ship captains, stay safe, and see you in the next episode.